For decades, we have been chasing one single question. Where does the universe end? And what lies beyond it? Right now, as you're watching this, you are sitting at the center of your own personal universe. Not because you're special, but because of a simple, brutal, mathematical fact. Light has a speed limit, and the universe has an age. Those two things together draw a perfectly spherical bubble around every observer in existence. Step outside your bubble, and you've stepped outside the reach of any light that has ever had time to find you. The radius of your bubble? About 46.5 billion light years in every direction. Let that number breathe for a moment. 46.5 billion light years. That's the distance light would travel if it ran, at full speed, without stopping, without slowing, for 46.5 billion years. And this sphere extends outward from where you're sitting right now in every direction. North, south, east, west, up, down, creating a perfect globe of perceivable reality 93 billion light years across. Everything you have ever seen in the night sky, every star, every constellation, every distant smudge of light that turns out to be an entire galaxy exists inside this bubble. Every photograph ever taken through every telescope ever built. Every alien civilization we've ever wondered about. Every answer to every cosmic question we've ever asked. All of it contained within this sphere. And here's the thing that should stop you. We have absolutely no idea what lies beyond it. Now, before we go further, let's address the thing that's probably already forming in your mind. If the universe is 13.8 billion years old, and scientists are pretty confident about that number, then how on earth does our observable bubble stretch out to 46.5 billion light years? That math doesn't work. If light has been traveling since the very beginning, and nothing moves faster than light, then the farthest anything could be is 13.8 billion light years away, right? Wrong. And the reason it's wrong is one of the most mind-bending revelations in the history of human knowledge. Space itself is moving, and space doesn't have to follow the speed limit. According to Einstein, nothing can travel through space faster than the speed of light. That rule still holds. No matter, no energy, no signal, no information can ever outrun a photon. But here's the loophole that Einstein himself initially refused to accept. The rule applies to things moving through space. It says nothing about space itself expanding. Think of it like walking on a treadmill that's moving faster than your legs can carry you. You're doing everything right. You're walking as fast as you possibly can. But the ground beneath you is moving backward even faster. And so, despite your best efforts, you end up behind where you started. Light from the early universe is doing exactly this. It's been traveling toward us for billions of years at the maximum possible speed. But the space between us and its source has been stretching, pulling that source further and further away. The light arrives eventually, but the place it came from is now much, much farther than the travel time would suggest. This expansion of space, this stretching, this inflation of the fabric of reality is not a new phenomenon. It's been happening since the very beginning, and disturbingly, it's accelerating. To understand why it's accelerating, we need to go back about a century and visit a man making one of the most consequential errors in the history of science. Albert Einstein, working through his theory of general relativity in the early 1900s, ran into a problem. His equations, the same equations that described gravity with astonishing accuracy, the same equations that predicted black holes and bent light, kept spitting out an uncomfortable answer. A universe governed by gravity alone would collapse. Everything would attract everything else, slowly at first, then faster and faster, until the whole cosmos crumpled inward under its own weight. Einstein didn't like this. The prevailing scientific belief at the time was that the universe was static, unchanging, eternal, just sort of sitting there. stars in their fixed positions forever, an infinite, motionless sea of light. So Einstein did something that, in retrospect, is almost charming in its stubbornness. He fudged the math. He inserted a new term into his equations, something he called the cosmological constant, which he designed to act as a kind of anti-gravity, a repulsive force distributed through empty space, pushing outward just enough to balance the inward pull of gravity, to hold the universe steady. He called it the greatest blunder of his career. But here's the extraordinary twist. He was wrong about it being a blunder. The cosmological constant is real. He just got the magnitude wrong. It's not balanced against gravity. It's stronger than gravity. Much stronger. And we now have a name for it: dark energy. Dark energy is the energy of empty space itself. And here's what makes it so alien to everything we intuitively understand about physics. The more space expands, the more dark energy there is. Empty space doesn't dilute as the universe grows. It multiplies. Every new cubic meter of void that gets created between galaxies is a new cubic meter filled with this outward-pushing, expansion-driving energy. Which means the further apart things get, the faster they get pushed apart. The universe isn't just expanding, it's expanding faster every single second. And the galaxies on the outer edges of our observable bubble are already moving away from us faster than light. They're not breaking the speed limit. Space is just moving them the way a conveyor belt moves luggage, no engine required. So what does the edge of our observable universe actually look like? It's not black. You might expect blackness, the visual silence of a universe beyond reach. But the boundary of our cosmic bubble isn't empty. It's a wall of light, ancient light. Light so old and so stretched out that our eyes are completely blind to it. When the universe was young, not stars and galaxies young, but primordially, incomprehensibly young, it was a hot, dense, opaque fog. Not empty space with things in it, just fog. Plasma so thick that light couldn't travel through it. For the first 380,000 years of existence, the universe was essentially opaque, a glowing, impenetrable murk. Then something changed. The universe cooled enough for electrons to settle into atoms. For the first time, matter became transparent. And all that light that had been trapped, bouncing around in the plasma fog, it was suddenly free. It flooded outward in every direction simultaneously, filling the universe in an instant. That moment of release is called recombination, and the light it produced is still traveling today. By the time that ancient light reaches us today, it has been stretched by the same universal expansion we've been talking about, from visible light all the way down into microwave frequencies. It's invisible, imperceptible, and yet it surrounds us perfectly. A uniform bath of ancient microwave radiation coming at us from every point in the sky with almost identical intensity. Now here's where the creation story gets genuinely strange, because the Big Bang wasn't what most of us were taught. At some point in your education, someone probably told you that the universe began as an infinitely small, infinitely dense point, sometimes called a singularity, and then exploded outward, like a cosmic grenade. But the Big Bang was not an explosion. It was an expansion, but not of stuff into space. It was an expansion of space itself. The universe didn't erupt from one single point and fill an empty void. Before the Big Bang, there was no void to fill. There was no outside. The Big Bang happened everywhere simultaneously, to all of space all at once. It didn't have a center. It didn't have an edge. Every point in the current universe was once a point in the pre-Bang universe, and all of those points expanded together simultaneously, equally. The cosmic microwave background proves this. If the Big Bang had happened in one place, the CMB would be brighter in one direction, the direction of the explosion. But it's not. It surrounds us. It comes from everywhere equally. The Big Bang happened here, right where you're sitting, and it happened 46.5 billion light years in every direction, and every point in between, all at the same moment. This is the universe we live in, not the tidy, clockwork cosmos of earlier centuries, not the static, eternal backdrop that Einstein once tried to preserve. Every galaxy beyond our local cluster is already receding from us, and with every passing billion years, more galaxies will cross the threshold of our observable bubble and vanish permanently from our sight. The universe we can see is actually shrinking, not physically, but perceptually. The cosmos is slowly, inevitably, pulling itself out of view. There will come a time, hundreds of billions of years from now, when an observer sitting on some future planet will look out at the night sky and see almost nothing. No distant galaxies, no traces of the cosmic web, just their own island of stars, alone in an apparently empty universe, with no evidence that anything else ever existed. In a sense, we are extraordinarily lucky to exist now, in this particular window of cosmic time, when the universe is still legible, when we can still read its history in the light that surrounds us. The real question isn't what's beyond the observable universe. The real question is, how much longer do we have to look? So, if you enjoyed this video, make sure to hit that like button, share it with your friends, and don't forget to subscribe for more amazing content.